age and height? How does age affect height?
As you like grow older, you go taller.
Exactly. Perfect. So we'll kind of that's kind of the thought there. How does temperature affect like ice cream sales?
Like if it's not like frozen, like cold, it's not gonna like no one's gonna want to buy it.
That's right. So like one affects the other. Like if it's hotter outside, people want ice cream. You can say the same thing though about temperature. Temperature is in other parts of the country, like jacket sales or sweater sales.
Mhm.
So that's the idea there. So I don't know what your teacher expects you to write down for number one, but I mean, any of these words would be good to include for that.
Mhm.
So give you a moment to get something down for that. And then we'll move on to number two.
Okay. Okay, we can move on.
Right. So for number two here, um, so there's two types of slopes. There's positive slope that has positive slope, and this has negative slope. Do you remember which one is increasing or which one is decreasing?
The positive.
This is increasing. So increasing means it's going up and to the right. That means that this other one is decreasing, which means it's going down and to the right.
Mhm.
So what does the slope tell you about whether it's increasing or decreasing? What's the relationship?
Like the negative and the positive,
Yes.
or
So if it's positive slope, that means it's
increasing,
increasing. And if it's negative slope, it's
decreasing.
yes. So I'd get something down in your notes for that.
Mhm. Yeah.
Right. Let's keep going here. Okay. I mean I mean I think these are tough because you really need the answer before you can even begin to you know like these are hard to do on kind of without even a lot of explanation. But what most of these problems are is they end up being like note cards or references. So it says what kind of graph shows the same output or y value for every input? And you might be like, well, what does that even mean? So let's do this. Let's make a little table here, x and y. X is the input, y is the output. Okay, so let's say x is 1 and y is 3. Now, what if x is 2? What does that mean for the same output? What would the output be?
4.
Same y value. It's got to have the same y value,
Oh, 3.
3. Okay, so let's go take a look at what that looks like graphically here. This is x, this is y. When x is 1, y is 3. When x is 2. And if we were to draw a line between them, let's add a couple more points here. Let's say it's 4 and 3, 6 and 3. What do you notice about this graph?
It's going by two, well, one side is going by twos.
Well, what you have this in on page the other page that mom sent. Let's see if I can pull it up here. Nope. Um, let's see. Okay, at the top, yeah, wait, it's at the top of this page.
Mm-hmm.
I'm gonna grab a snip. I was trying to find it. I thought it was on the other page. So, no, I picked. All right, what I'm showing you here in this graph is the same as this right here. What do you know about that part about the graph?
It's constant.
It's constant, yeah. So that's what they're trying to get you to say here. So you have to know whether something is
Oh,
constant, or whether it's increasing, or whether it's decreasing.
okay.
Okay, so that's the answer to number 3. Um, so number 4 is correct, but you need some more words. It's like writing a definition down. So yes, it is increasing from 1, but why is it increasing? You want to say because it's going up and to the right. Why is it decreasing? Because it's going down and to the right. That's what your instructor is looking for.
Okay, yeah, that makes more sense. Like that.
So you will probably take geometry at some point, almost certainly, and the answer isn't as important as the explanation. That's what this is saying. Like they're grading you on how well you explain it, not that you've got the right answer, which is often difficult. It's often really difficult to do. Okay, very good here. Now, your answers are all correct here, but I think what they're looking for here is for you to say increasing, just to organize your answers slightly differently, decreasing, and constant. They want you to say, okay, it's increasing on 3 and 4, decreasing 2 and 6, and constant, what did I miss here? 1 and 5. They're looking for, I think, this kind of organization. Yours is correct. It would just be a preference to do it that way.
Okay.
Any questions on that?
No.
All right. All right, let me grab the next one. Oh, let's go to that one. See if I can find it. Okay, so let's grab number 6. Do you have a test coming up or a quiz or?
No.
Okay. And this is very different than what we were doing the other day. Is this just a little surprised? It seems like it's something you wouldn't see quite yet, but um, you've got this correct, and this correct. Um, this is excellent. Do you have any questions on this? I mean, you seem like you definitely understand this part of it.
Yeah, I understood it really well.
Okay, that's good. So for 7, let's talk about,
Yeah, I didn't finish it.
okay. So is this an increasing or decreasing relationship?
Decreasing
Why is it decreasing?
because it's going down to the right.
Down and to the right. It's as simple as that. Down and to the right. Very good. Okay, so the decreasing relationships, there's two variables. There's time and there's temperature. So for a decreasing relationship, everything I'm about to say is just for a decreasing relationship. As one variable increases, the other variable decreases.
Mm-hmm.
So as you go to the right, as time goes up and temperature goes down. Now it's also the case that if time goes down, temperature goes up.
Mm-hmm.
So these arrows are meant to represent like the two possibilities. Okay, so now when it says describe the relationship between the two variables, what your teacher wants you to do is to pick one of these, like maybe the top one, and write a sentence. As time increases, comma, what can you say about temperature? Does it go up or down?
It goes down.
Temperature decreases. And that's what they're looking for. Your teacher wants you to write a sentence to describe it.
Yeah.
Okay, so let me give you the other possibility that you might see, which is an
Mm-hmm.
increasing relationship. So let's talk about, we talked about this earlier, temperature. So temperature can go on any axis, and ice cream cones. I'm sorry. Yeah, ice cream cones. Is this an increasing or decreasing relationship?
Increasing.
It's increasing because it's going up and to the right. So now we can say the same thing. Temperature and ice cream. As temperature increases, ice cream increases. As temperature decreases, ice cream decreases. Do you see how the arrows go in the same direction?
Uh-huh.
Great. So now you can write a sentence. And let's pick the first one. How would you write a sentence, kind of like I did up here in red? How would you write a sentence here for this? What would you say?
Um, as temperature increases, ice cream uh increases.
It's, yes, that's correct. Okay, good job. So this is kind of note card stuff if you want,
Mm-hmm.
but we'll see. All right, let's look at number 8 together. You have a device that monitors the voltage across a lamp over time. Results are shown in the graph. Describe the behavior of the function in each interval. Increasing, constant, decreasing, constant. Perfect. Like you said, you've got a pretty good idea on that. Um,
Mm-hmm.
all right, so now number 9, your answers are all correct. Um, but it asks another little thing here. So it says figure out where it's increasing, circle where it's increasing. I think highlighting it's kind of a good answer here too. It's all of this, it's all of this, it's all of this to the top. And the answer for where is it increasing the fastest or the greatest? I don't know if you've ever been hiking, but there's hikes that are like this, and maybe like that. Which is the steepest?
Uh, the third one.
The third one. So this would be the fastest, and this would be the slowest.
Mm-hmm.
And it's the same going the like if you were to go down, it's like what would be the fastest going down that, or that, which yeah, it would still be the fastest.
Mm-hmm.
The slowest.
Mm-hmm.
All right, so I'm looking at number 10. All right, so they're asking you to think about uh they're asking you to like give a scenario here.
Mm-hmm.
Scenario like at time zero you speed up and then you're at constant speed. This will be easier once you're driving, but constant speed means the same speed the whole time. Can you think of a situation where you're at the same speed the whole time?
Um, maybe like running.
You're in a car. Think about being in a car.
Oh, like going, I'd say like at a flat surface.
Okay, yeah, this is tough because you're just not you don't drive. There is a third interval here. Don't forget that one's also counting.
Oh,
So I'll give you an example. This is when the car is at like a traffic light. What's your speed when you're sitting at a traffic light?
0.
Zero. Yeah. And think of one and two as when maybe you're like at what's called cruising speed,
Mm-hmm.
the speed limit, unless you're going to be a speeder, but speed limit.
Mm-hmm.
Okay. I believe that takes care of everything that you had sent over. We would now just have some time to review unless you have other things you want us to work on today.
No, we can review.
Okay. So we'll see how this goes. I'm going to pull up some problems for combining like terms, what we did last time,
Mm-hmm.
and we'll just see where you're at with this. So let me just put a couple problems up in front of you. So I always start out by just putting up a problem just to see, can you do it, not do it, ask me some questions or not. Um, but let me know what your final answer is.
Would it be n minus 7 plus 9n?
What's the number? There's some things that are okay, but let's go talk about this. What's the number in front of n that is not written?
In front of n?
Yeah, what goes in front of n?
1.
One. All right, I'm going to circle the like terms. So what is 1n plus 9n? What does that become? How many n's?
10n?
10n. Okay, so I didn't hear that from you, but that's okay. Now the operator always goes with it. So it's minus 10 minus 3. They're same sign. What does that become?
Negative 7.
They're
Or
same
7
sign.
7.
So we talked about writing down some rules for same sign last time. First
Yeah.
is that you keep the sign, that's for sure. And then you add the numbers without the sign.
Mhm.
So what are the numbers without the sign?
10 and 3.
Okay, so what do those add up to?
7.
You keep
Oh,
giving me,
add.
uh,
Add,
yeah,
sorry.
add,
13.
yeah. Okay, so that's negative 13.
Oh,
Okay, this would be good time to get some of this down in your notes again. We've got to get this down where you can remember it. Um,
I got it down.
So let's do we'll make up another one like this. Could you try this one for us, please?
Mhm. Would it be 5x plus 13?
Check your signs. Check that one more time.
Um,
Yeah, what I'm really asking is what is -8 minus 5? Remember, you keep the sign. That's the first rule.
mhm.
And then you add the numbers without the sign.
Yeah, so it'd be 13 or negative 13.
Yes. Okay, so that is correct. Okay, let me see if I can find a few more here that are up to the challenge. Like, I don't love any of these. There's another one. All right, here's another one for you to try.
Would it be negative 6n minus negative 5?
This is what you said. Is that what you meant? It's okay
Uh-huh.
to make changes.
Yeah, that's what I said.
Okay, so let's just say this was correct. One of the main problems is you would never have a double negative in your answer. You'd
Oh,
want to.
sorry. It was just net minus there was no net other negative.
Okay, so give me your final answer one more time.
Negative 6n minus 5.
Okay, all right. So I see a 1n and a -5n. Are those same sign or opposite in sign?
Um, Opposite sign.
Okay, so what is the rule for opposite sign?
Um,
Do you remember from the other day?
don't you keep the sign that's furthest from 0?
So you determine the sign.
Mm-hmm.
Okay, so you determine the sign, and it's the one that's further from 0. So which is further from 0, 1 or -5?
Negative 5.
Okay, so if the answer is negative, then you subtract the numbers without the sign. Okay, so
Mm-hmm.
you say, okay, I got 5 and 1, I subtract them.
It'd be 4.
Okay, so it's -4n. And then for the next ones, you've got that correct. +4 minus 9 is -5.
Mm-hmm.
Any questions on that?
No.
Okay, let's try a couple more here. You have to know these two rules. When they're same sign, And when that's fine. You just have to get those down in your notes or be looking at them. Let's go 12r minus 5 minus 3r minus 5 like that. Go ahead and give that a try, please.
Would it be positive 9 r minus 10?
That is correct. Good. Okay. Let me see what else I've got here. All right, so we're gonna increase the difficulty slightly. These are kind of like the ones we were doing last time, which I can't remember when that was, but go ahead and give this one a try, please.
Would it be positive 13x plus 8?
So we're gonna talk about this. So these two right here, 2 plus 7, 2x plus 7x is 9x, 9x minus 6x plus 8.
Mhm.
So these two
Oh,
right here, what would that?
wouldn't that be? Oops, wait, I added on accident. Sorry, I didn't mean to say 13. I meant to say positive 3x plus 8.
Right. The good news is like math, math exams aren't like an oral exam or anything like that. You don't, but the way we do it, that's why I always ask you kind of, is that what you meant? Just to confirm.
Mhm.
All right. All right. So here's a new one for you to try.
Okay, would it be positive 3x minus 7?
It is. All right, good job on that. So the next like sort of increase in difficulty to these questions is where they use letters that kind of look the same, and P's and Q's are one of them. So, I like to circle or underline like terms. You really want to do something. Uh, you want to really be careful that you are identifying the like terms, 11Q minus 9Q plus 5P plus 7P, something like that.
Mhm.
Give that a try, please.
Okay, would it be positive 2q plus 12p?
Very good. Yes, exactly right. Okay, so I think we did some slope stuff on one of our very first lessons. Does that sound right to you?
Uh-huh.
We looked at some lines. I'm going to put some numbers in front of you. It's kind of a lot like what we've been doing before. What is 5 minus 3 over 6 minus 2? What's the top? What's the
Would it
bottom?
be would it be 2/4?
Okay, so this is a fraction. Does this reduce?
Yes.
Okay, what does it reduce to?
1/2.
1 over 2. Good. Very good. Okay. Now, let me just let's try another here. Let's go 1 minus 3 over 4 minus 9. What does that become on the top and the bottom?
2/5.
So it's negative 2 over negative 5, which does reduce to 2 over 5. But my concern is, did you get the negatives?
Yes.
Okay, that's great. Let's try some more here. Let's try a 5 minus. Now, I don't know if we've seen this. Do you remember what to do with a double negative?
No, I don't remember.
Okay, so we'll talk about that. And then we'll go minus 4 plus 2. Okay. What is negative 4 plus 2? Let's look at the bottom first.
Oh, would it be -2?
Yes. Now on top, the double negative becomes a positive. What is 5 plus 7?
12.
Okay, what's 12 divided by negative 2?
6.
Well, so you've got a positive or a negative.
Positive 6. Wait.
-6.
Oh. Oh, I see.
Any questions on that?
No.
Okay, let me actually see. I've got something from another student that could be pretty useful here. Uh, nope, that's not what I want. Here we go. All right, here's something else to try. This we're just working on signs of numbers. Just a quick review on that. Could you give me the answers to each of these, please?
Mhm.
Like, what do you, for the first one here, do you remember if the answer is positive or negative? -4 times 5?
It would be negative.
Yes. Okay, and what about two negatives? What does that become?
A positive.
Okay, so +48. How about when you're dividing two negatives?
Um, I don't remember that.
So it's just like multiplying two negatives. So if you
Mhm.
divide two negatives, it's positive.
Okay.
And here you've got one positive and one negative. What does that become?
A negative.
There you go. Okay. Here's a couple of more same sign, opposite sign problems here for you to work on. This is all just review. You're doing really well. I'm just trying to find some stuff to give you. Um, so take a look at that. Let me know what you come up with.
Okay, would the first one be -18?
It is 18, but it's positive. Why is it positive?
Is it because the 30 is bigger? Or is closer?
Yes, exactly.
Okay. And then would the second one be +62?
They're both negative though. So since they're both negative, the answer must be negative. So you're mixing up the rules for multiplication and adding and subtracting, which is quite common. So just keep that in mind. It's -63. How about the double negative here? What does that become?
A positive,
Yes. And the last ones, they're same sign. So what does that mean for the answer?
a negative.
Yeah. All right. We're going to go ahead and stop there for today. Very good. All right. So I will see you next week.